Now that we know how to identify significant digits, we need to learn how to use the properties in multiplication, division, addition, subtraction, and when they are combined. The easiest of the rules are when you multiply and divide. The first step you will do is calculate using proper order of operation that you learned in math. After you do your calculations, you want to count the number of significant digits in the original number. The final answer will have the least amount of significant digits. Let's look at our first example. It's a multiplication, so we're going to multiply 0.00300 times 3,496 times 3.400 times 10 to the third. If you do your math correctly, you should get approximately 35,659.2. That's step 1. Now I'm going to go back to the original problem and count the number of sig figs in each of the original numbers. So if I look at 0.00300, there are two sets of zeros, right here at the beginning and then after 3. Since there is a decimal present, I look for a significant digit in front. There is no significant digit, so these are placeholders. The zeros behind the 3 are significant because there is a decimal present anywhere in the number and a significant digit. So the first one will have 3 total significant digits. The second number will have 4. These are all non-zero digits, so they are all significant. The last one is a scientific notation, so we ignore the exponent and everything in front is significant, so there is 4. Now that I counted all the significant digits in the original number, my final answer must have the least amount. So my final answer must have 3. Starting from the left, I count 3. 1, 2, 3, leg 1 to the right. And just like math, 5 and higher rounds up, below 5 rounds down. So it becomes 3, 5, the 6 becomes a 7. Since the 6 is in the hundreds place, my final answer, the 7, must be in the hundreds place. So we have to add 2 zeros as placeholders. So my final answer is 35,700. Pause the video, try the next problem on your own, and check your answer. First step you're going to do is multiply 4.93 times 7.000, then divide by 0.00040. If you did the math correctly, you should get 86,275. Step 2, you're going to go back to the original problem and count the number of sig figs in each of the numbers. 4.93 has 3 significant digits because these are all non-zero digits. 7.000 has 4 significant digits because there's a decimal present and a significant digit, so these zeros are all significant. 0.00040 has 2 sets of zeros. The first set are placeholder because there's a decimal but no significant digits, so it does not count. The second 0 is significant because there's a decimal present and 4 is in front of it. So the bottom number has 2 significant digits. After counting the total number of significant digits in each of your numbers, it is the least amount. The least amount is 2, so my final answer must have 2. Starting from the left, I count 1, 2. I leg 1 to the right. 2 is less than 5, so the 6 stays. So this becomes 86,000. Again, we need to place zeros for placeholder because the 6 is in the thousandths place. Pause the video, try these problems on your own, and check your answers. On problem 1, you're going to multiply the numerator together and then divide by 100. If you did the math correctly, you should get 631,6800 or 6,316,800. After you complete your math, you need to go back to the original problem and count the number of significant digits in each number. The first number, 987, has 5 significant digits. These zeros are significant because there's a decimal and a significant digit in front. The second number is a scientific notation, so we ignore the notation and everything in front is significant, so this one has 3. 100 only has 1 significant digit because these are trailing zeros. So my final answer can only have 1 significant digit. Starting from the left, 1, I look 1 to the right, it is less than 5, so the 6 remains. Again, the 6 is in the millionths place, so we must add zeros as placeholders. Number 2, if you multiply the numbers correctly, you should get approximately 16,329,600. Now I go back to the original problem and count the number of significant digits. 0.09000 has 4 significant digits. These zeros in the front are placeholders. There's a decimal, no significant digit in front of the 0, so this is not significant. This second set is significant because there's a decimal present anywhere and a significant digit in front. 567.000 has 6 significant digits. There's a decimal present, a significant digit in front, so those zeros are significant. 32,000 has 5 significant digits because there's a decimal present anywhere it's written and there's a significant digit in front, so all these zeros are significant. After I count the number of significant digits in each, it is the least amount when we multiply and divide. So the least amount is 4, so my final answer must have 4. I start from the left and I count 4. 1, 2, 3, 4. I look 1 to the right. It is greater than 5, so the 2 becomes a 3. And again, we must add zeros as placeholders. Since the 2 is in the 10,000ths, where we round it must also be in the 10,000ths. So my final answer is 16,330,000. If you calculated number 3 correctly, you should get approximately 249.864869. Now go back to the original problem and count the number of significant digits in each number. 430 has 2 sig figs. This 0 is a trailing 0. Why? There is no decimal present anywhere. On the bottom, this 0 is significant. Why? There's a decimal present and a significant digit in front. So 74 has 3 significant digits. 10 has 2 significant digits. This 0 is significant because there's a decimal present here and a significant digit in front. So my final answer can only contain the least amount, which is 2 sig figs. So starting from the left, I count 2. 1, 2. I look 1 to the right. Since the number is greater than 5, the 4 is going to round up to a 5. Since the 4 is in the tens place, I need to add a 0. We add a 0 as a placeholder. Do not write a decimal after. If you write a decimal after, that makes this 0 significant. So this answer has 3 significant digits, not 2.